Sorry about that. We had a little mishap getting some windows put in the house, so we had a little tripping of the cords in my desk. So we were right here in example 4. I'm going to go back over this because I'm going to put that in a separate video. I'm going to go ahead and upload that, and we'll pick up here. So the population of the city increased from 23,400 to 27,800 between 2008 and 2012. Find the change of population per year if we assume the change was constant from 2008 to 2012. So we're just looking at the change in the population. That's it. So when I see that, the first thing I see is, okay, in 2008, the population was 23,400. In 2012, the population was 27,800. Remember, time is always your independent variable, and it decides what your output is. Okay, so 2008, 23,400, 2012, 27,800. I'm using my slope to find my rate of change. M equal y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So y sub 2, I went ahead and labeled them, 27,800 minus 23,400 divided by 2012 minus 2008. All right, let's just calculate these real quick. So we have 27, let me move this, 800 minus 23,400. And that's equal to 4,400 over 4 equals 1,100. So what does this mean? It just means the population is increasing because it's positive, is increasing. You only want to use increasing or decreasing on this. Increasing by 1,100. Now, the way to find out what the units are in this is to go back to the original portion of this. Where did these numbers come from? Well, these are representing population, and this number down here is representing years. So currently the population is 1,100, but we don't have anything in the denominator. So that's an assumption of 1 automatically. So 1,100 divided by 1 will give us our population per year. Okay, so the population is increasing by 1,100 people per year. And anytime you have a rate of change, you're going to have a 2-unit portion to this because it is divided in order to find the information with the increase in, with the independent and dependent variables. All right, let's move to the next piece, example 5. Write an equation for the linear function, all right, given this graph f. So the first thing I want to do is find 2 points. The first one's easy. I would like to know, so we want it to be f of x is equal to mx plus b. B is easy because we already know where it's intercepting the y-axis. All right, that's our initial value, and that's going to be positive 2. So right now we have f of x is equal to something x plus 2. All right, the next portion of this is to find out what is our slope. Now, there's a few different ways we can do this. The first one I'm going to show you is just choosing 2 points on the line and solving for m. That's it. The other way is to go through and say, okay, well, from my initial, point here, where am I hitting another point? So here's a point right here. I'm going to show you these 2 versions. This one, I would go 1, 2, 3, up 3 and run 1. And you always run to the right, which is why I didn't choose down here, because I wouldn't be able to run to the right to find the information. So from my point, I'm rising 3. Well, no, these are in 2 increments. So 2, 4, 6, and running 2. So 6, I'm gonna write this over here. 6 divided by 2 is going to give us a 3. That's going to be what our slope is. But let's check it using these 2 points. Let's use the point 2, 8. And I'm just going to use the 0, 2. So m equals x1, y1, x2, y2, y sub 2 is 2 minus 8 over 0 minus 2 is negative 6 over negative 2, which is 3. Spot on. All right, so there's our slope. Write the equation. There you go. Example 6, write an equation for a linear cost function. Okay, there's a couple things you need to understand here before we start talking about it. There are there's a couple different functions regarding businesses that we're going to just talk about briefly. One is profit, one is revenue, and one is cost. The revenue and the cost function are always going to be positive. You're going to think of them in terms of just themselves, because when you think of cost function, the first thing that comes out of your mouth or your mind is subtraction, because it's costing something. But what you need to understand is the profit is equal to the revenue minus the cost. So the subtraction is already figured in for you. Revenue function needs to be positive. Cost function needs to be positive, because this negative is going to distribute over the cost function to subtract everything from it, okay, to find your profit. So when you think of it this way, this next piece will make a little bit more sense to you the way I'm going to set it up. Suppose Ben starts a company in which he incurs a fixed cost of $1,250 per month for the overhead, which includes his office rent. His production costs are $37.50 per item. Write a linear function C, where C of X is the cost for X items produced in a given month. Okay, so we're just going to write a function C of X. And again, we're back to a word problem again. So the first thing out of my mind is going to be B plus MX. I really want to set it up in that manner. And where B is my initial value, which is 1,250. And to that, what's the rest of his cost? Where he's going to also have $37.50 per item. There's your cost function. Okay. Next one. Write an equation for a linear function given 2 points. All right. So what you need to understand is this f of x is equal to y, right? F of x is equal to y. So the 3 is your x, the -2 is your y. 8 is your x, 1 is your y. We've got 2 different points here. So we've got 3, -2, and we've got 8, 1. I'm going to label them x1, y1, x2, y2, because I know I'm going to find my slope. Find an equation for the function in slope-intercept form. Cool beans. So m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. 1 plus 2 is 3. 8 minus 3 is 5. We're back to this one again. And what else? Oh, they want us to find an equation. All right. So if I'm going to look at f of x is equal to mx plus b, I've got my 3/5 for my coefficient of x, for my m. That's what I've got so far. The next piece of this is to find b. Now, to find b, you can plug in either one of these 2 points to find what b is. All right, so I'm just going to randomly choose, I guess, 3 and -2. Remember, f of x is equal to y, so that's going to be my -2. And then b is going to be 3. All right, I'm just going to solve for x to find out what my b is. Okay. I'm so sorry. I am losing my mind. I'm like, this doesn't feel right. -2, 3/5. X is actually 3. We're solving for b. There we go. That makes me much happier. So the first thing, I know y'all don't like fractions, and it seems that I've talked to a couple of people recently, and they're really struggling with this. If you see a fraction, start off by multiplying both sides of your equation by that denominator. So I'm going to multiply this side of it by 5, and I'm going to multiply this side of it by 5. 5 times -2 is -10. And then over here, so you have to distribute this 5 over your binomial. And when you do that, this 5 is gone. So now we just have 3 times 3. This 5 is times b, which is 5b. Okay, we're just going to solve for b now. I'm going to subtract 9 from both sides and divide both sides by 5. So b is -19/5. So f of x equals, let's see if we can see all this, 3/5 x, and it's -19/5. Here's our answer for that in slope-intercept form. you have any questions, let me know. All right. Modeling real world problems. You know what? I'm going to make another video for this one. So hold up.